Hello, it's Mike McGinn, and we are going to talk about our last chapter in this course, which is it's a network, baby. And this is kind of a tie it all up in a nice little bow kind of a chapter, but for most part of it, and then we get into some iOS image management towards the end of the chapter. So we'll jump right in here. I'm going to go through this as quick as I can because first half of the chapter is quite a bit of fluff. Basically, they start talking about uh, network topologies, small networks versus large networks, and they show you a diagram in 11.1.1.1 of the small network, and this is pretty typical where you've got a switch, endpoint servers plugged into the switch, and a perimeter router that's connected to the internet. A lot of small companies, that's basically all they got. Um, And so that's a small network. Then they talk about, factors to consider when choosing a device for your network. Cost is obviously one of the biggest considerations um, because, small business money's tight. And so you have to really keep in mind of what you're going to be able to get through the financial manager of the company in terms of capital expenditure for equipment. But given that constraint, which is an organizational constraint, you have to look at what functional needs you actually have and the type of ports and the number of ports that you need in your network equipment is important. Making sure that it can handle the amount of traffic that you want to have run through your network, the types of traffic, etc. Uh, ports, you can get switches that are basically expandable and modular, or you can get fixed switches that just have a certain number of ports of a different type. Of course, the modular switches are more expensive than the non-modular ones, so those are always considerations that you need to have. And then you've got the speed consideration. How fast do you need your switches to be able to shoot data down the wire? And it used to be 10 gigabit was fast, and then 100 came out, and we thought, oh boy, and now the standard pretty much is gigabit for client PCs. Still see some 100 out there, and the switches, 100 switches obviously are a lot less expensive than gigabit switches on where it's gigabit on all ports. So from a fiscal constraint or a financial constraint, you may need to go with 10-100 switches. Those generally come with a gigabit backbone port, so you can interconnect switches with at least a gigabit backbone um, and that sort of thing. So that's one aspect of speed. The other aspect of speed is how fast is the switch actually switch packets. In other words, take it in one port and forward it out the other. And the more expensive the switch, unfortunately, the faster the switch is. So a $100 24 port off the eBay, you know, cheap Linksys switch is not going to run as fast as a Catalyst 2960 24 port switch because it's the components and the technology inside the switch itself allows that switch to switch packets a lot faster. So you can have all kinds of wire speed, but if your switch can't keep up, that's a bad thing. Usually what I see on networks is I see very little of the throughput being tied up by the bottleneck being wire speed. It's usually in the switch itself. It just can't push the data around fast enough. Expandable versus modular devices. Again, I talked about this a little bit already, and expandable gives you more flexibility. It allows you to have mixed media ports on a specific device. So on a modular switch, you can have a certain number of say fiber ports or 10 gigabit Ethernet ports for backbone utilization and give you that flexibility. But again, switches with card slots tend to be a lot more expensive than your fixed type ones. But they do give you a good level of expandability and that you can take advantage of. And then, the manageability of the switch, being able to have features in the operating system of the switch or router that allows you to do the things you need to do on your network. What kind of security features does it have? Does it, what are the quality of service capabilities of it? If you're going to be running voice, can it, does it allow for voice over IP, and will it support power over Ethernet to power your IP phones? Do you need power over Ethernet to power your wireless access points? Another thing is to consider is do you need layer 3 switching? Does your network have multiple VLANs, and is there any inter-VLAN routing that you need to do at the switch level? Those are considerations. And then for your router do you need network address translation? If it's a perimeter router or switch, then you may. If it's a perimeter router or a firewall, you most likely will. DHCP, ideally, in my opinion, you want DHCP services to be on a server in your server farm, so that the DHCP services, for example, in a Windows platform, it will integrate with DNS to auto-register your hosts and DNS and that sort of thing. So there's a lot of good reasons to do it on a Windows server. But in the absence of the Windows server and configuring it on a domain controller, you can also often configure DHCP on a layer 3 switch, on a access point, or on a perimeter router or firewall. Then they talk about IP addressing. You can setting up an IP scheme for your organization, or understanding what your IP scheme is, whether you're looking at it by location, if you have a wide area network type of scenario. If you got VLANs in your network where you need separation between departments because of what type of work they do. And then also by device. And so, within a subnet, usually these locations and departments are going to make you choose different networks. But within a network, usually there's some categorization that we like to see by devices. Sometimes you'll see servers on their own subnet, but in a small organization, typically what you see, and I'll just give you an example of a /24 network, for example, 192.168.1.0 /24 network. Generally what I like to do is take the bottom, say 20 or 30 IP addresses and use those for servers. And then maybe the next 20 for network attached printers, and then maybe the next 100 or so for endpoints that IPs are being handled out through DHCP. And then the top part of the range I'll use for my network equipment, firewall, etc., with usually the .54 or the last IP in the subnet being used for my perimeter router or my default gateway. So that kind of consistency will pay. I don't really like to see people, create exclusions in their DHCP scope for fixed IP devices. That's just sloppy in my opinion. I think what you do is if you do your IP planning properly on the front end and you leave yourself groups of IPs that are available for fixed IP addresses, it just kind of makes things a little bit cleaner. They talk about redundancy, where you dual home devices, so you got multiple paths in case of a failure. This is all technology that's getting more momentum as the cost of hardware has come down. And design considerations in a small network. It's important that you as an IT manager or an IT support person have a good understanding of what's going on in your network in terms of what traffic is on the network and what its relative priority needs to be. So that's also important. Activity here on kind of what we just talked about, and then in 11.1.2 they talk about protocols that might be running on your network. So these are all different things. They show them as separate servers, but usually a lot of these may be running on one server. For example, on a domain controller offering, you'll see DNS, you'll see DHCP. on a domain controller. So a lot of times these things can be combined. They talk about real-time applications where some protocols that you often see there, voice over IP, those are going to be high real-time applications because the quality of service is so important, as well as IP telephony type of applications, and then streaming video or video conferencing often uses RTP and RTCP to be able to efficiently transmit video data across the network using quality of service mechanisms. So growing to a larger network, bottom line is make sure your documentation's good. You know, get yourself a copy of Visio, which is an Office application, and make yourself Visio drawings of the documentation. Make sure you've got an inventory of your devices. Make sure you know what your costs are on your current network. How much your licensing fees are, your subscription fees for like antivirus. What is your hardware maintenance agreements costing a year? All of that is really important as you manage an IT infrastructure. Traffic analysis, knowing what's going on your network. What protocols are running, what applications and services are running, and what are their respective traffic requirements. Those are all things you need to know as you look at growing your network to make sure you make the right decisions. Doing a protocol analysis on a network, Wireshark is a good tool to use for that. It'll tell you what is running on a particular segment and what their relative load is. Running this on a backbone segment is a good way to know exactly what's going on your network. And they talk about keeping the network safe, and a lot of this stuff is common sense, but it's amazing how much lack of common sense is out there when it comes to keeping your network safe. But there's really four major areas where we have need for security against hackers. You've got people out there that want to, just steal your proprietary information and sell it to competitors or whatever. You also have people that just want to get in there and screw the data up or manipulate it to be different than what it's supposed to be for whatever agenda they may have. Then you've got people that are trying to steal identity information so that they can sell it, credit cards, etc. We've heard a lot on the news about that. And then you have just people that want to shut you down, put you down and create havoc for you through disruption of service. These are all, things that we see out there all the time, and things that you have to mitigate against where your budget will allow it. This is also overlooked, physical security. I'm amazed at how many people stick their servers for a small business in a janitor closet, and with 20 people having keys to it, or not locked at all. We see it. Ideally, you want to have your equipment locked up, and if you're a growing business, and you got to build a new room for a data center, even for a smaller, medium-sized business, you want to have raised ceiling. You want good cooling and adequate power in that particular room. And ideally, you want to be able to monitor and control the entry into the room, either through security cameras or electronic logs if you've got passkey access to the door. Generally, you want to get away from key lock, as traditional locks where you just need a physical key to get in because keys can be duplicated. Having access codes that can be changed in the event of employee turnover and such like that is usually the better way to go. And we talk about different types of security weaknesses. You've got weaknesses in different protocols that can be exploited. You've got operating system weaknesses. You've got weaknesses in specific types of devices. My advice is to use business class network equipment. Don't use SOHO or home-based equipment under any circumstances. you'll find that generally those are a little bit more hardened against security vulnerabilities. Configuration weaknesses, how you set up your users often is something that's done sloppily and inconsistently. Not non-complex passwords is really common that we see networks that aren't very secured. People configuring devices when they don't know what they're doing for internet services, uh, or writing software so that things can be exploited. Um, using unsecured default settings within products. Many, especially low-end products, have default settings that enable security holes. And just network equipment in general that's misconfigured. For example, inadequate or non-existent access lists or routing protocols or SMP community strings that can open up large security holes. Then there's the human element, policy weakness, the lack of a written security policy by the organization that says this is how we're going to secure our network and this is the way we're going to enforce it or apply that security policy. Dealing with the turf battles and politics within the organization is always a challenge. Common thing we see is the engineers, because they're engineers and they think they're so smart, and a lot of them are a lot smarter than me, think that because they should have pretty much carte blanche to the network, even though you're their IT guy. That's a not common turf battle that you have to deal with. They want administrative access to their computers so they can install software willy-nilly and that sort of thing. And even though that's not a best practice, a lot of times those politics come into play, and you got to play the game. As your first job, if you get your first job as an IT guy in a company and you decide you're going to pick a battle with a department because of their security policies, you may not be there very long. So choose your battles carefully, and definitely get buy-in from the people that you're accountable to before you make any significant security changes in your organization. That's just a matter of survival. Lack of authentication continuity, poorly chosen, easily cracked or default passwords is really common. So you should have a automatically applied password policy through group policy on, say, Windows Server as an example, to make sure that password policies are adhered to. They expire when they're supposed to expire. They require the proper amount of complexity in their composition, etc. Making sure you've got access control lists on data paths, file shares, printers, etc. You don't want to give everybody access to the payroll check printer, I think that's self-explanatory. Making sure that unauthorized changes to the network topology or installation of unapproved applications is not easily done on your network is a good thing to do, because software and hardware changes usually open up exploits, and unless they're authorized, there's no accountability. Again, that's the reason why I don't like to see administrative rights to a user on their own computer, and definitely not on a server. Only people that should have administrator rights on a server are going to be the people that actually maintain the server in the IT department. Disaster recovery plans, more often than not, especially in small businesses, are non-existent. So as you grow, you want to have some sort of a plan so that if you have a fire or you have a major outage, tornado, disgruntled employee with a sledgehammer, whatever it may be, you've got some sort of a plan that you can recover as quickly as is indicated by management in terms of that event. So we got an activity on security threats and vulnerabilities, go through that, and then we talk about vulnerabilities and network attacks, and this is pretty much standard stuff you probably have heard of all before. I will talk about denial of service attacks. Denial of service attacks are attacks where a lot of times these are botnets that organized crime has, where they've got millions of computers on the internet and they can flip a switch and they can flood a particular IP with all kinds of ICMP packets, thus shutting down or overwhelming that particular web server. This is often method of which these organizations will apply extortion to an e-commerce business and say, if you want me to shut off this denial of service attack, use Bitcoin and send me to, $5,000 and I'll stop. This is something that's often very common. These attacks usually come from outside the United States, but United States businesses are a big target. Kind of like the ransomware, but only from shut down a server from overwhelming it with non-legitimate traffic. Mitigating attacks, obviously you want to do your OS patches. You want to make sure you've got good backups, and you've got a backup strategy that makes sense for your organization. Backup technology now, they can do a snapshot every 10 minutes. So, if you want to, if you do just a full backup once a day, that may not be adequate for your organization. You got to look at, what kind of pain are they going to feel if they got to restore a full day's worth of work from backup. So having a right backup strategy, using the right backup software and technology is very important. Doing your upgrades religiously on a scheduled basis, using the right tools to do automatic updates where need be. These are all things that are important. So these are all things that you have to look at. Antivirus software is extremely important, and endpoint antivirus is often used. I would recommend essentially managed antivirus software for a network of about any size, where you have the updates, the signature files deployed from a central local server, and you have a management console so you can look at all the devices on your network and know what their virus status is, as well as their update status as far as signature files and client software. Trend Worry-Free Business Security is an excellent product that I have a lot of experience that does this. They talk about authentication, authorization, and accounting. They use an analogy of a credit card. I don't know that this really makes sense, but basically AAA is basically where you are for network use or network resource use. 1A, first A stands for authentication. That's basically proving who you are, and there's various mechanisms to do that. Radius and Tech, ACS Plus is a couple of technologies that do that. Authorization, once you are authenticated, make sure the policies are in place so that that user can only get to the things that they're authorized to use, like only certain printers, only certain file shares, only certain parts of the network, and etc. Accounting is just keeping track of what people are doing, so that you have transaction logs as to what that person accessed and what they tried to access and failed. These are all mechanisms that have to do with AAA. Today, talk a little bit about firewalls. Firewalls are generally for perimeter security, making sure that bad people on the outside or unauthorized people on the outside don't get into anything on the inside. The Cisco ASA security appliance is an excellent platform for most businesses as far as a perimeter firewall. It has, with their firepower services, the ability to do things like URL filtering and monitoring of web browsing and things like that. Packet filtering and stateful packet inspection are common features of about any business class firewall, ASA included. ASA is an appliance-based firewall. You can also get server-based firewalls. I'm not a big fan of those, but a lot of people like them. Integrated firewalls, which are firewalls that are integrated into a perimeter router, those are very common. The Cisco ISR platform gives you that capability, the integrated service router platform. And then personal firewalls reside on host computers and are not designed for LAN implementations, but they may be available by default from the OS, and a lot of times companies will turn those on if they don't create too many problems for them in terms of allowing their software to run network applications. Endpoint security, a secure network is only as strong as its weakest link. So, you got to make sure that you've got, you know, security on everything that touches your network, or you're managing security, whether they be laptops, desktops, servers, smartphones, tablets, etc. Um, Making sure that if you've got a wireless network that you segregate your legitimate network traffic from your guest network traffic. A lot of companies allow people to hook up to the Wi-Fi with their smartphones so that they can keep track with, do web browsing on their phones and that sort of thing. But you want to be real leery of letting any wireless device on your network. Uh, Wide open guest networks are not advisable. They're primarily there for vendors that need temporary access to the internet, or for employees that need non-business application access to the internet. Everything else should be on the secured uh, um, wireless network and with access control lists and network access control mechanisms in place. And they go in and they talk about passwords and basic security practices that on a Cisco device. So there's, for example, they talk about password strength in terms of weak passwords versus strong passwords, basic security, and they show you how you can, what you do on a Cisco router to provide encryption of passwords, and they show you the commands there. And enabling secure shell on device. And you can access a Cisco device either through Telnet or through secure shell. You just need to keep in mind that when you Telnet to device, everything is going through clear text to the network. When you use secure shell, you're employing a encrypted protocol or tunnel to the device when you're accessing the console or doing uh, configuration of the device. There's a lab on accessing a network device using secure shell. That's important. So that's something that I think you're assigned. And then they talk about basic commands, the ping command, the traceroute command, various show commands that are out there. You need to be familiar with those, and I'm just going to leave you to kind of go through those uh, as well. There's some packet tracer here using show commands. I highly recommend you go through that. And then some host iOS commands. ipconfig, that's something that is used all the time on a PC to find out what the network configuration is. The purpose and the use of the ARP command on a computer so that you know what the MAC address pairing is. Show CDP neighbors is a way that you can see what is directly one hop away from any Cisco device as far as other Cisco devices. That's a common command that's used. The IP interface command is used a lot so that you can see what all ports you have on a device and what their IP address is and whether they're up and whether they're running a protocol. Those are all important. You can also do pings from the Cisco device as well as a traceroute. So there's an activity on doing show commands, and then using CLI to gather network device information. That's also an excellent lab as well. And then we get into managing iOS configuration files. Where particular file types are stored, what's in the flash file system, what's in the NVRAM file system, as well as on a switch, the same thing. So go through those, make sure you understand that. Processes for backing up and restoring configuration files. They talk about how you can you can take a output from a terminal session and log it to a file. Backing up and restoring using TFTP server, actually the configuration files themselves. And using the USB ports on a router to copy your configs to a USB port. I'm not a big fan of using that, but it can be done. So there's a packet tracer on backing up configuration files and that sort of thing, and then some other labs as well. Then they talk about integrated service routers. They talk about a multi-function device that does multiple things. It's a router, it's a wireless access point, it's a slicer, it's a dicer, it's a food processor, etc. Different types of integrated service routers, wireless capabilities, and they talk about different wireless modes, and this is stuff that's not really tested on in the final exam, but this is all just good common knowledge that you may want to know as you work on your home network, etc. And they actually talk to you about it, configuring a basic Linksys router. So some pretty basic stuff. You can, I believe there's even a Linksys router that you can figure out within packet tracers. So yeah, there is a packet tracer for that. So you get through the labs and the packet tracers in this chapter, you're going to pretty much know all this stuff from, let's see, it's from about 11.3 on down. Is all stuff that's kind of preparing you for your labs. So go through that, read through that real good, and then do your labs and packet tracers, and you should have that area down pretty good. So that's chapter 11. So my next presentation will be just information on the finals and when, where, how, and what to do, and I'll enable I'll enable a practice final for you, and also and I'll figure out what we're doing in terms of hands-on, whether we do it in Net Labs or I give you a packet tracer to do. That's still yet to be determined, but I should know that here in the next day or so. So I'll talk to you all again soon. Bye.